Okay, guys, today I'll be going through review exercise 10. So let's start off with the first question, which is question 12 lah, or under review exercise 10. Okay, so in the diagram, right, they say that AC is the diameter of the circle with center O, and then angle ABF, right, and DCF, they are straight lines. Okay, and then they meet each other at F lah. Okay, and then AC and BD intersects at E. So given that BAC is 20 over here and angle CAD is 37 over here, find angle BCD. So first thing first, find angle BCD. So BCD is over here, this entire thing. Okay, so in short, right, it's made up of BCA plus DCA, correct? Okay, so first thing first, I want to find out what is BCA. So for part A, right, angle BCA, right, is actually equals to 180 degrees. Okay, first thing first. Okay, let's not even go there first. So first thing first, because AC is the diameter, right? So we can say that angle ABC is equals to 90 degrees. Why? Because right angle in a semicircle. Okay, so this is 90 degrees. Okay, so in order to find out what is ACB, so angle ACB is equals to 180 degrees minus 90 degrees minus 20 degrees. So 70 degrees. All right, so this is sum of angles in a triangle. Right, so this part here is 70 degrees. Okay, so same thing for, I need to find this angle. Okay, so same thing for this, because AC is the diameter, right? So ADC, this is also 90. So angle ADC equals to 90 degrees also. Why? Because right angle in a semicircle. Okay, so this is 90. So that means angle ACD is equals to 180 degrees minus 90 degrees minus 37 degrees, which will give me 53 degrees. So sum of angles in a triangle. Okay, can. So lastly, angle BCD is just add up lor, 53 degrees plus 70 degrees, which will be 123 degrees. So this is it for part A. Okay, so part B, ABE. Okay, let's see. ABE over here. Okay, okay, I'm going to fill in the blanks first. So ABE, this one. This is the one that they want to find. This is 70. This is 53. Yes, so they want us to find this, right? So, oh, actually, okay, very clear. Okay, so if you see properly, A, B, E, A, B is, this is what they want to find, right? But it's, I mean, it's the same as ABD, right? So we can say that ABD is equals to ACD, okay? Angle ABD is equal, okay, okay, to be clearer, angle ABE equals to angle ABD, right? So angle ABD is equals to angle ACD, right? Which is equals to 53 degrees. How come? Because angles in the same segment. All right, so this is 53. So angle ACD, I mean angle ABE is 53. So this is 53. Yeah. Okay, so let's move on to part C. Part C says AED, right? AED, this one. Okay, so this one is what they want. Okay, so basically, let's take a look. I definitely need to find out what is ADE lah, this angle over here. Right. So this angle over here, mm, okay, got it. So angle ADB is actually equals to angle ACB. Say equals to 70 degrees. How come? Because same thing. Angles in the sa- same segment. Okay, so A, D, B, then ACB. Yeah, excuse me. So ACB. So 70, right? So that means this is 70 as well. This is 70. So that means angle AED equals to 180 degrees minus 37 degrees minus 70 degrees. So that will be 73 degrees. Okay, so sum of angles in a triangle. So this is 73. Okay, so this is 73. Okay, so the next one, part D, last one. So angle AFD. Okay, so the one outside over here. So they want this. Okay, so let's see. So hmm, okay, I think I got it. Okay, I want to find out what is BDC first. Okay, so BDC over here. So I can say that angle BAC equals to angle BDC equals to 20 degrees. Why? Angles in the same segment. Angles in the same segment. Okay, so this is 20 degrees. Okay, so then if you think about it, angle AFD, angle FAD, and angle ADF, they all add up to be 180 because they are all in a triangle. So that means I can say that angle AFD equals to 180 degrees minus 20 degrees minus 37 degrees minus 70 degrees minus 20 degrees. Oops, 20 degrees. Yeah, okay, that's it. Equals to, uh, which is 90 minus 20. Okay, just give me a while. 33 degrees. Yeah, okay, so sum of angles in a triangle. Okay, yeah, so very lengthy because there's a lot of reasoning that you got to write lah. Okay, so yes, this is it for question 12. Okay, guys, let's go through question 13 together. So the diagram shows a circle with center O, right, and radius RCM. So as you can see lah, center O, radius RCM. So this is also R. Okay, then A, C are points on the circle. A, B are tangent, is a tangent to the circle at point A. Okay, angle AOC is 62 degrees and BC is 8 cm. So find the value of R. So in this case, right, we are very sure that part A, part A, right, we can say that angle OAB is 90 degrees. How come? Because tangent perpendicular to radius. Okay, understand? So this is actually a right angle triangle. Then that means we can use the properties of Tuakaso, right, to help us to find out what is our R. So basically, yes, OA is also R. So that means we can use, okay, so 62 degrees is the reference angle lah. So opposite, adjacent, hypotenuse. So we can use cosine, car. So cosine 62 degrees equals to adjacent over hypotenuse. So R plus 8. Okay, so let's just do a bit of manipulation and then we will be able to find out what is our R. So R plus 8 times cosine 62 equals to R. So let's expand this. R cosine 62, right, plus 8 cosine 62 equals to R. So R cosine 60, okay, R minus R cosine 62 degrees equals to 8 cosine 62. So R equals to, okay, R, factorize our R. So 1 minus cosine 62 equals to 8 cosine 62. So R equals to 8 cosine 62 over 1 minus cosine 62. Okay, which will give me, let's see. So it's quite a bit of manipulation to be done. So let me know if you don't know how to, like, which step is unclear so I can address this again. Okay, so the answer is 7.07930, round up 3SF, 7.08 cm. Okay, so this is for part A. Okay, part B. Okay, part B, as you can see, they say area of shaded region, right? But my diagram got no shaded region. Okay, so sorry about that lah. But I'm just going to assume that the shaded region usually is this over here. Okay, so in short, we have to find what area of triangle minus area of sector. Okay, so R we have found out, right, to be 7.08. Okay, so area of triangle OAB lah. I'm going to use half AB sine C. So half times 7.0793A times B, which is 7.0793 plus 8. Okay, then times sine 62 degrees. Okay, so that will give me half times 7.0793 times 7.0793 plus 8 times sine 62. So that will give me 47.1277. Okay, so now for area of sector, OAC, right? So it's equals to 62 theta over 360 times pi times r squared, 7.0793 squared. Okay, so this is 62 over 360 times pi times 7.0793 square. Okay, so this is 27.1156. So area of shaded, right, region is equals to minus lah, right? So 47.1277 minus 27.1156. So this is equals to 7.1277 minus 27.1156. So that will give me 20.0121, round up 20.0 centimeter square. Okay, yes, so this is it for question 13. Okay, let's go through question 14 together. So in the diagram, O is the center of the circle. AC and BD intersects at E, then AD and BC when produced meets at F lah. So angle means when you extend the line from AC, from AD and BC, right? Extends the line and then it will meet at F lah. Okay, so CAD is 18 and AFB is 23. So find angle ABC. So angle ABC is over here. The big angle over here. Okay, so let's see. So actually, okay, so if you see angle ABC is a combination of angle ABD, right, and angle CBD, correct? So this angle ABD is actually 90. How I know? Because you look at ABD is a triangle, right? So AOD is the diameter. So ABD is 90 degrees. This is 90 degrees because right angle in a semicircle. So we can say that angle for part A, so angle ABD equals to 90 degrees. So right angle in a semicircle. Okay, so that is 90. And then also angle CBD. Okay, so angle CBD is equals to angle DAC, which is equals to 18 degrees. Yeah, because why? Angles in the same segment. Okay, so that means and therefore angle ABC equals to 90 degrees plus 18 degrees log, which is 108 degrees. Okay, so this is for part A. Okay, so for part B, angle BAC. So let's see, BAC, this angle over here. Okay, so let's take a look. Mm, Okay, we know the angle BAC is equals to this angle over here, lah. Right? Angle BAC equals to angle BDC. Is there a way we can find that? Uh, Actually, no need lah. We can find out what is angle ACF, this entire thing. Hmm. Yeah, we can find out what is angle ACF. Then after that, find out what is this angle. Then we can find this already, lor. So angle ACF equals to 180 degrees minus 18 degrees minus 23 degrees. How come? Because ACF is here, right? So this entire thing is a triangle. So it's just sum of angles in a triangle, lor. So 180 minus 18 minus 23. So that will be 139 degrees. Okay, so this is sum of angles in a triangle. So this is 139. So that means angle ACB, right, is equals to 180 degrees minus 139 degrees, which will be 41 degrees. Okay, so this is adjacent angle on a straight line. Okay, so this is 41. This is 139. Okay, can already lah. So angle BAC. So angle BAC equals to 180 degrees. Okay, BAC is over here, right? So look at angle triangle BAC, right? It's the entire thing. And then we found ABC just now, ma. So that means it's just 180 minus 41 degrees minus 108 degrees. Okay, so 180 minus 108 minus 41. So it is 31 degrees. Okay, so this is again sum of angle in a triangle. So this is 31 degrees. Okay, so part 3. Oh, okay, yeah, it's part 3. It's not even ABC. Okay, so this is part 2 and this is part 1. So part 3, angle BCD. Oh, okay, they want the whole of angle BCD. Okay, can. So, okay, erase first. Okay, I erase first. So angle BCD is over here, this entire thing. All right, so look at ABCD. Okay, this is a cyclic quadrilateral. Okay, so that means BCD, right, this angle plus BAD, this entire angle is equals to 180 degrees. So angle BCD is equals to 180 degrees minus 31 degrees minus 18 degrees, which is 131 degrees. Okay, why? Angles in the opposite segment. Okay, this is one of the angle property. All right. Okay, now going on to the last part, part B. So show that ACF, ACF and BDF. Where's BDF? BDF. Oh, okay, show that they are similar. Ah, okay. So that means we got to show that they are similar, right? Let's see. So ACF and BDF. Okay. Eh, Okay, there are many tests of similarity, lah, right? So maybe we can first think about AA test first, right? Because it's the easiest, right? Two angle can ready, ma. Okay, so that means let's see, let me see. A, F, C, B. Oh, okay, can, I got it. Okay, so that means, if you see closer, right? Angle FC, right, is 23, right? AFC is 23, which is also equals to angle BFD, which is 23, correct? 23 degrees, common angle, right? They are essentially the same angle, lah, right? AFC, this one, BFD, this one also, right? Common angle. Okay, so that's the first A. Second, um, second is FAC, angle FAC, right? Is also equals to FBD, angle FBD. Why? FBD, okay, which is 18 degrees. How come? Why is this 18 degrees? Okay, because just how we done it in other parts lah, or rather in part A here. Okay, so you can see CBD is 18, right? CBD is like here, is this thing also, 18 degrees, right? So this is actually same thing, angles in the same segment. So angles in the same segment. Okay, so therefore, right, by AA similarity test, comma, triangle ACF and triangle BDF are similar. Okay, yep, so AA test. Okay, and this is it for question 14. Okay, guys, let's go through the last question of review exercise 10, question 15. Okay, so just give me a moment. So in a diagram, TCS is a tangent to the circle, right? With center O, and then angle AOBT is a straight line. So AOBT is a straight line, and then BT is 4 cm, CT is 7 cm, and BTC is theta degrees. Okay. So they want us to find all this angle in terms of theta lah. So first thing first, right? Angle BOC. BOC is over here, right? So they want us to find this. So if you think about it properly, right? ST is a tangent to the circle at C, right? And OC is the radius because O is the center of the circle. So that means we can say that this is 90 degrees. So angle, how come? Because angle OCT equals to 90 degrees because tangent perpendicular to radius. Okay, so that is 90 degrees. Okay, so in short, let's find angle COB lah, BOC lah. So actually, you look at COT is a right angle triangle, so we can use Picasso law. So that's a reference angle. So this is the opposite. This is the adjacent. So tangent theta equals to what? Opposite. Actually don't even need. Yeah, I don't even need to do that. I'm not finding length, right? Yeah, I'm just finding the angle over there. So actually, if you see, this is 90, right? This is theta. So this is 90 minus theta lah. So angle BOC is just equals to 90 degrees minus theta. That's for part I. Okay, part 2, so angle OAC, this one. Okay, yeah, very simple. So angle, okay, so since angle COB is 90 minus theta, so that means angle COA, right, is 180 minus 90 minus theta, correct? Adjacent angles lah. So it's actually just 90 plus theta. Okay, so COA is 90 plus theta. Why? Adjacent angle on a straight line. Okay, so that is 90 plus theta. So angle OAC. Oh, okay. Angle OAC, right, is actually equals to angle OCA. How come? Because OC and so it's an isosceles triangle lah. Because OA and OC is radius of the circle. So angle OAC is just 180 minus 90 plus theta over 2. Okay, which is the same as 90 minus theta over 2 lah. Okay, so that is angle OAC. If you want to write as 45 minus half theta, that is fine also. Okay, can? Then last part, part 3. So angle ACS. So ACS is over here. This angle, ACS. So if you can also see, that means we SC OCS, right? OCS is also 90 degrees lah. So ACS is equals to 90 degrees. So angle ACS equals to 90 degrees minus 45 minus half theta lah. Okay, let's just use this. All right. How come minus that? Because ACO, right, or rather OAC is the same as OCA. Yeah, so it's the same thing. So we can just minus lor. So it's just 45 plus half theta. Okay, so that's for part 3. Then the last part, part B on the left. So part B, find the radius of the semicircle. Okay. Basically just look at triangle OCT lah. Okay, OCT. So this is OC is R lor. Right. And then OB is also R. Then CT is 7. So we can actually just use Pythagoras theorem lah. Yeah. So I can say that, R square plus 7 square equals to R plus 4 square. So nothing to do with Picasso. You can actually no need to use Picasso or anything like that lah. So R square plus 49 equals to R square plus 8R plus 16. So 8R equals to 49 minus 16, which is 33. Let me just check. Okay, yeah. So R equals to 33 divided by 8, which is just 4 whole 1 over 8 cm. All right. Okay, yeah. So for part D, we actually make use of the Pythagoras theorem to form an equation and then solve for R. Okay, yes, and this is it for question 15. Last question of review exercise 10.